4. Yeah, so what's the problem with 4?
No, it's right. Circular motion.
Circular motion, okay. Which number?
4.
4. Will we do it?
No, I just want to know because it's easy, but...
Is it easy? I don't think it's that easy.
I don't know why they add 30. Why is 30 added? And
Yeah, so it's not easy then, because that's actually a key thing in the question, the 30. I'm going to do number 4 now on circular motion page, okay? So let's have a look. A girl swings a 3-kilogram ball in a vertical circle of radius 3 meters. So it goes around like this, okay? And here it is at the top. Okay, and the mass is 3, and the radius is 3. And I want, and you have the time. The time is 0.5. By the way, if the time is 0.5, what's the frequency? Yeah, which is 2 then. And what's the omega? That's 2 pi, that's 2 pi over t. So 2 pi over 0.5 is 4 pi. Yeah, okay, anyways. Something interesting happens here, because there's 2 forces. There's the weight, and the weight is always present. But there's also the tension, the force and the strain. Now what's interesting here is that this force is actually in opposite directions. When it's down below, this tension is working against the weight, in the opposite direction. In fact, which is bigger here, the T or the W? No. Which is bigger? T, yeah. Why is T bigger, Chow? Don't, go on, give me your... Try. We're all friends here. We understand.
Because it's right.
True, it is right, yeah. Okay, the T must be bigger than W because it's moving in a circle, and when something moves in a circle, there must be a force to the center. So the T must be bigger than the W, okay? So the T must be bigger than the W. And there's another force here, also a tension, and this tension is different. I call it S. Now, which is bigger here, S or T? Now, picture doing this with a rope, and picture the ball going around. Is the tension at the top bigger or smaller than at the bottom, if you can picture the strain? Yeah, it's smaller. In fact, if it's smaller, and sometimes if it's small enough, when the ball makes it to the top, it falls down. Yeah. So the S is smaller than the T. Now why? Well, the T needs to be big because it has to cancel the weight. Whereas here, the tension can be smaller because the weight is helping it move in a circle. You see, in both pictures, here there's a total F, and that F should equal T minus W. But here there's the same F, but that F must equal S plus W. So although the centripetal force is the same, it can only be the same if the tension is changing. So it's a little bit complicated. Okay, let's continue here. Come on, move. I can't seem to. Oh, there we go. Right, now, Newton said F is equal to ma. Yeah? So we can say T minus W equals m, and the A is V squared over R. But what's the formula for V? Because we don't know V. Remember the formula for V? V equals omega R. So I can actually change this into m omega squared R. So I now get two equations. T minus 3g equals 3 times 4 pi squared times or. What's or? 3. And I also get S plus 3g equals m omega squared or. Did I do that right? Yeah? Is that okay? So, do we have enough information here to get T and S? We do. What should I do here? I should add these guys together. Actually, no, I don't even need to do that. Sorry, what am I saying? I just need to bring this over to the right and that 3g over to the right. So now I have my answers. So the T is, what's that? 4 squared is 16. 16 times 9 is 160 minus 151, is it? 16 times 9, please? Is it 151? Is it? Okay, yeah, no, 144. What am I saying? 144 pi squared plus 3g, and S equals 144 pi squared minus 3g. So that guy there, that's going to be the bigger one. So that's 1451. Sorry. That's 1451 newtons, and that one there is 1392 newtons. Okay, so that's number 4 there. Ah, good coffee. Yeah, it's okay. Did you get this one okay yesterday? Yeah. What do we need to see next? Yep. Which one? 6 and 7. Tricky ones, huh? Okay. Back to conservation momentum, 6 and 7. How did you do in number 5, Kim? Yeah. 5 was okay? Yeah. Okay, continue? Okay. I don't think there's a lot of people dressing up. I think you've got a good chance of winning. Because the teachers are dressing up, but they're not allowed to enter the competition, so. Okay, you have that now, George? Yeah? Okay. We'll see, but you could go as a patient. Yeah. Could pretend you're sick or something. Right, 6 now. A 0.17 kilogram snooker ball is travelling at 10 meters per second when it collides with another snooker ball, which is at rest. And as a result, 5% kinetic energy is lost. Find the speed after the collision. Yeah? Okay, so firstly, after the collision, what do we think will happen? Will this ball move to the left or move to the right? Afterwards, we think it'll move right. But this one's a little bit harder. What do we think about this one? Now you need to kind of think of a snooker. You know, if the white ball hits the red ball, what tends to happen after the collision? Slows down, but it still moves in the same direction. So we'll call this one P and this one Q. Yeah? After the collision. So you have M1, U1 plus M2, U2 equals M1, V1 plus M2, V2. Yeah, is that okay? Dun, 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 dun. So you get P plus Q equals 10. Okay, is that okay so far, Kim? That's okay so far. Now, let's have a look at the energy. So what is the energy before the collision? That will be a half m v squared plus a half m v0 squared. Right. What's that? 100 times 100. 8.5. Thank you. 8.5 joules. That's the kinetic energy before. Now, what is the kinetic energy afterwards? Will it be more or less than this? Less. How much less? 5% less. So, Sipa, can you just multiply this number by 0.05 and we'll just figure out what that is?
0.425.
Okay, now we need to take that away from this. So that would be 8.075 joules. That's okay so far, yeah? So, we also know that a half m p squared plus a half m q squared, that should equal the 8.075. Because we just said the kinetic energy should be this. Right, I will multiply everything by 2. So, I'll also divide by 0.17. So I'll get p squared plus q squared. Now, Siva, can you just do 8.075 multiplied by 2 and then divide that answer by 0.17?
95.
Is exact 95? Sweet. 95. You agree? You got 95? Alright, okay. Do you want to double check? Because I don't trust Hellraiser here. What else do you have with your costume? Do you have something to wear? Or it's the helmet. I like it.
Yep.
No makeup or anything? Isn't Hellraiser white?
Yeah.
Yeah, so you might need to get like white face paint or something, you know, just pull it on. Huh?
No, ask Neil Gilligan. Neil, coming? Is it?
It is 95? Okay, great. Right, now, how can we solve these two equations? What's the best method you have from your maths class? Sub, yeah, what do we sub here? What do we do next? Yeah, you could say P equals 10 minus Q here. Yes? And then you can put that in here. So P equals 10 minus Q. 10 minus Q squared plus Q squared equals 95. So that is 100 minus 20Q plus Q squared equals 95. 2Q squared minus 20Q plus 5 equals 0? Oh, does this have factors? I don't think this has factors.
9.74.
It doesn't. Okay, what are your two answers?
9.74 and 0.26.
Okay, and then when you go back, look, if you go back to this formula, you can get the P easily. So, you'll get the P here. P will equal 0.26, and then the Q will equal 9.74. So which is the right one? Is it this one? Or is it this one? Because actually one of them is right and one of them is wrong. Now, we might have to go back to our picture to figure out which is the right one. So, what do we think? In other words, which do we think is bigger? In this case, the Q is bigger, and in this case, the P is bigger. So if we look back, which one do you think will be bigger after the collision? Yeah, because when you think about when the white ball hits the red ball, comes in, smashes the red ball flies away, and then the white ball is left to move slowly afterwards. So, also the Q has to be bigger than the P, because if the P was bigger, then it passed through the Q. So the Q has to be bigger, which makes this one the correct one, and this one we should reject them. Yeah. Okay. What do you think, Kim? Okay? Not okay? It's okay? Yeah. Okay. Yeah, we'll just give you a minute to write that down. There's a long question. I have bad news. They sometimes ask you for this one in the exam. Now, it's not very common. I think I've only seen it twice in 10 years. But it has come up in the exam. It's not very bad, but when you're in the middle of an exam and you're sweating and you're stressed, then it looks worse. Right now we're relaxed, we're drinking coffee, we're doing questions. It looks fine. It's okay, but you know, when your future depends on it, then that changes your attitude.
No, compared to like other projectile stuff.
It is a bit better than some of the projectile questions. Yeah. I mean, really, it's like a maths question, isn't it? One linear and one quadratic. Where are you at in your maths class now? Have you finished sequence and series? Are you on to logs yet? No. Or powers, indices? You're still in sequence and series chapter.
I think
the limits, yeah.
We're going to start next week maybe.
The next chapter then. Yeah, okay. Right, continue. Going to do the next one now. Isn't that what you said, Kim? Number 7 as well, yeah. Right, number 7's an interesting one. We have a table here. So I kind of need to draw it as a story. So the story starts off like this. You have 2 blocks of 2 kilograms each, side by side on the table, and they're connected by a 1 meter string. So you have a block here, some string, and a block here. And then this guy gets knocked off the table. So obviously he's going to fall. And then what happens, after a little bit time passes, the string becomes tight. And then what happens to the first block here? It gets pulled then. So it's kind of, I was kind of picturing they're side by side like this, and then that gets knocked off, so then it falls. But then when it falls enough, the string becomes tight and then pulls the other block. So I'm kind of interested at that moment. Just that moment. I want to know, how quickly will this move? So it's at rest, and then all of a sudden it gets yanked. How quickly does it move forward? Okay. So what we should do first is we should first figure out how fast this one is going. So it's just falling, okay? Because this string is loose, it's not pulling it. So it's like it's fallen freely. So what type of problem is that? That's UVATS. The U is 0, the V is what we want, the A is minus G, the T we don't know, but the S we do know. What's the S? Minus 1. Or rather, it's nearly minus 1. Like it falls, and then it gets to nearly minus 1, and then when it gets to minus 1, it tightens. So it's about minus 1. So I'll just actually say S is roughly minus 1. It's practically minus 1. Okay, so what gives me the V here? V squared? V squared equals U squared plus 2AS. 2 times A, I think this. Yeah, so the V is square root 19.62. 4.43 meters per second. Okay, now, you might think that's the answer. That you have the block, it's fallen, it reaches a speed of 4.43, and then it pulls the other block. So you might think, oh well, so logically, if this is going 4.43 when it pulls the other block, then this block here must then be moving at 4.43. But it's not this, okay? It's not this. Because what happens if you can look at my hands, okay? So this block is fallen, it's fallen. Okay. This guy has momentum, true, and this one doesn't have momentum. And then when this pulls down and moves him, he has momentum. But the momentum he got, it must have came from this guy. You know, because remember, the momentum is conserved. So right before the string tightens, all the momentum is here. Then the string tightens, and now they share the momentum. It's actually like a collision. You have the momentum, and then something happens, and now there's the total momentum is the same, but their speeds are different. Do you think he will move faster or slower after the string is tightened? This bottom one here. Slower, yeah. Yeah, very good. So, if we think about it as conservation momentum, you have M1, what's M1? 2. U1. Now, M2, U2. And my $1 million question is it a plus or minus 4.43? Now, don't just say it, think. Because we're trying to make this like a collision. And collisions happen in one direction. So you kind of have to use some imagination here. Do we take it as a plus or a minus? What do we think?
Which one, the fallen one or?
Yeah, the fallen one, yeah. Yeah, do we use plus or minus? What do we think? You're going with minus. Who would agree? I want to see. I want to see like what's the split. Like who thinks you have to choose one. So who's going to choose plus and who's going to choose minus? So Matt, you're opting for minus, and you would choose. Well, you have to pick one. What would you pick? You changed your mind. Okay. All right. Siva, what do you think? You go with plus because Matt picked plus, or you were going to say plus? Yeah, and Kim? Yeah, but why plus? Yeah, they're both kind of moving to the right, aren't they? Even though this one is kind of curved over the table, they're both moving rightwards in the collision. So it is a plus, very good. Equals M1 V1 plus M2 V2. Now, why am I saying V1 and V2? They're both V's. They move off together when the string tightens. It's like they're connected now. You know, like with the ice skaters. So you get cancel. V plus V is 2V. So what happens? V is 2.215 meters per second. So when the string tightens, its speed suddenly halves. Now you look at this and you realise there's not a lot of calculations here. It's just a lot of thinking. Okay. What do we want to see next? Now don't forget, you said you want to have tutorials on Monday and Thursday. So if you didn't have time to try all the questions, you can wait until Monday after you tried them. I don't know how much you've done last night. So anyways, for you, Kim, conservation momentum is finished now. What about for circular? How far did you get in that last night, or what's the story with it? Yeah. So like math, for example, which question are you at in circular? Okay, you're halfway through, yeah. And George? Right.
I'm like at 3 to 5.
Yeah. And did you try 6 or 7? Or you didn't look at them yet?
No, I looked at 6, I couldn't do it in 7.
You really couldn't do it? Or you looked at it and said, no thank you?
No, I did what you
conservation of momentum.
Oh no, look
No,
at
no,
the
no.
next one, yeah.
circular motion.
Yeah.
No, because I remember from my club.
We had 6 of them. Do you want to look at circular now, or do you want to do that on Monday's tutorial? What's our thoughts?
Monday.
Yeah, well, I know you're behind because you're sick. Were you watching any of the videos while you were sick? Steve, what else were you doing when you were sick? Were you watching Netflix?
No, rubbing lotion.
For the whole week? Kim, circular motion today or Monday? What do you think? Like, have you finished all the questions, or do you want to?
I think so 6 and 7, but like I don't know.
Yeah, okay, but you still have to do 6 and 7.
Yeah.
You haven't tried it yet?
I tried a little bit, but I couldn't.
So you don't, today or Monday, it doesn't matter for you, yeah. Andek, what are your thoughts on it?
Maybe Monday.
Monday, yeah. Chow? Monday? Okay. We'll, I'll probably end up doing 5, 6 and 7 on Monday. Yeah. But try your best to figure it out on the weekend. I mean, just think about how satisfying it would feel if you figured them out before Monday. Very satisfying, I would say. Yeah?
How do I write the omega symbol?
You really don't like the omega symbol. Like this. And this is capital omega. This is small w, and this is big W. So different. How are you writing omega?
Normal W.
Very different. How's your Greek letters? You know all your Greek letters? This one?
Yeah, alpha, beta, gamma.
Delta.
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 E.
Epsilon.
Epsilon is a German.
It is as well, yeah.
Y.
It's like that Y thing,
Yeah.
isn't it? Yeah. This one, you know? No, you see, okay. I think you should maybe do this in your EAP class. Iota. Iota, eta, kappa, eta, kappa. Okay. These letters are used a lot in physics, so you might want to take some time to, look them up and try to remember some of them. Yeah. I think you know this one. You do. No. You know this one. This one here. It's a Pokemon.
Ew.
Yeah, correct. Pokemon number 151. Correct. Yes. Okay, we'll continue now. We'll continue the tutorial on Monday. So we'll have a look now at the next topic. Yeah, the next topic is like circular. It's quite a big one. I don't know if we'll get to do it all today. Come on, close.